Hi students, welcome to the problem solving session on source free RL circuit. Let us see this problem. Find VO of t, that is this one, if I of 0 is equal to 2 ampere and V of t is equal to 0. So we have to find this VOT. So what is the condition they have given? V of t 0. So if V of t 0 means it is short, right? So the circuit becomes like this. 1 ohm, 3 ohm, then 1 by 4 Henry. So I have to find this VU of t, right? So how can we find, before we find V, we have to find I. Then only we can find I into R, that is equal to V. So let us find I of t value. For it is a source free RL. You see R and L are there, so it is a source free RL circuit. For source free RL circuit, so this is I of t. So for source free RL circuit, I of t is equal to I of 0 e power minus R by L t. So I of 0 they have given, it is 2 ampere. R by L only we have to find. So L we know, L is equal to 1 by 4 Henry, right? So what is the only thing we have to find? R. That is also very easy to find. R is equal to these two resistors, right? 1 ohm plus 3 ohm, right? So these two resistors are in series, so 4 ohm. So what is my I of t? I of t is equal to I0 is 2, right? E power minus R by L. R is 4, 1 by L is 1 by 4, so it is 16. 4 by 1 by 4, 16. So I of t we found. Next what we have to find, we got I of t. I of t is current flowing through this branch. VO of t is given by the drop across the resistor. So I of t into R. I is, so this is plus minus, right? So we can find VO of t is equal to what is the thing? Okay, write it. So this is the drop across this, right? So I write here. This is what, if this VO of t is same as voltage drop across this. So I write as, okay, this is what VO of t. So I write VO of t is equal to, so current through this I of t into R. That is what will drop across the resistor, and drop across the inductor is L into di of t divided by dt. Okay, so I of t is nothing but this one, 2 into e power minus 16. R is 3, so 6 into e power minus 16 t plus L is 1 by 4 d by dt. I of t is 2 into e power minus 16 t, right? So if you simplify, what you get is minus 2 into e power minus 16 t volt. That is what VO of t for this problem, right? Very simple problem, right? Okay, next one. Find I of t for t greater than 0 if I of 0 is equal to 2 ampere. This is, you see here we have a dependent source, so it is somewhat critical, but we can solve very simply. Let us see this. What I have to find, we have to find I of t, right? So this is what our I, so this only we have to find. Okay, so we have dependent source. So when you want to find I of t is equal to I of 0 e power minus R by LT. So first I have to find I of 0 they have given. So I of 0 is 2 ampere. R by L I have to, L I have, so L is also have. R is nothing but Thevenin's equivalent resistance. In order to find Thevenin's equivalent resistance for dependent source, what we have to do? We have to remove this inductor by using either voltage source or a current source of 1 volt or 1 ampere respectively. So I replace this inductor with 1 volt voltage source, right? So this is, I write as minus plus, this is, okay, then this is what I do. I replace inductor with 1 volt voltage source. This is 10 ohm, this is 40 ohm, this is 0.5 I, right? Okay, let me assume here it is current flowing through this is I1, this is I they have given in the problem, so this is I1. Let us assume this current flowing through this branch is I2, right? So this is I2. Okay, fine. So now what I want to find? I want to find Thevenin's resistance. Thevenin's resistance is given by V by I. So I want to find I value, right? V is 1 volt, right? That is what I given here. This 1 volt, V is equal to 1 volt divided by I value. So I have to find the current flowing through this branch. So how I am going to find? I write KVL for outer loop. So it is 10 I1, right? And so when it is plus minus, so when current flows through this in this branch, what is the drop? 10 I1, right? Here 1 volt negative terminal is encountered, so it is minus 1. Then I come here, see I am writing the KVL for outer loop. 40, again it is plus minus, so 40 I2 is equal to 0. That is the first thing we have to note. This is equation number 1. We got this. So from the diagram we understand I is equal to I1. I is equal to I1 and I1 is equal to I2, right? So I is equal to I1 and I1 is equal to I2 plus 0.5 I, because this is 0.5. So I1 is equal to I2 plus 0.5 I. Yes, I1 incoming, that is equal to outgoing current I2 plus 0.5 I. So reduction is equation number 2, equation number 3, right? So you substitute I is equal to I1, so I2 plus 0.5 I1, this is I1, right? Here you substitute 2 in 3, we get this. This implies I1 is equal to 2I2. We know I1 is equal to I, so I1 is equal to 2I2 is equal to I. Hereafter everything is simple. Now we substitute I2, we know what the relationship between I2 and I1. So substitute here from this 10, substitute this 4 in 1, 10 I1 minus 1 plus 40 I2. 40 I2 is equal to 20 I1. Because 2 I2, so I can write 2 into 20 I2. 2 I2 is I1, so 20 I1. 20 I1 is equal to 0. From this I can get I1. I1 is equal to 1 by 30. That is equal to I, because I1 is equal to I. Right? So what is R Thevenin? R Thevenin is equal to, I told, V by 1 volt by I. I is 1 by 30, so it is 30 ohm. R Thevenin we got. So now everything is very simple. So what is I of t? I of t is equal to, from the formula we know I of t is equal to I0 2 ampere, right? So I0 is 2 ampere, e power minus R by L. R is 30, L is 60 t. So 2 into e power minus 5t, I of t ampere. Right? So I hope understand this problem. If you have any doubt, please ask me in comment section. I will clarify. Thank you.